This is problem number 2 from exam 1. The differential equation given is x to the fourth dy over dx is equal to y minus xy. And assessing this differential equation, we can tell that it is a first order because we have dy over dx. That is a first order differential, so it is first order. We know that it is linear because all functions of y are to the first power, meaning that they're linear. And we can also tell that it is homogeneous because we don't have any standalone functions of x. So we have an x here multiplied by a y prime, essentially, and an x here multiplied by y. So it is all homogeneous. And for the purposes of this video, we are going to keep this as the final assessment of this differential equation. It's going to read differently, but we know that for the whole video, it is a first order linear homogeneous differential equation. And looking at this differential equation and looking at its characteristics, we can take a good judgment call that it's going to be variable separable method. So let's try that out. Method. So first thing I would do is to look at this side of the equation. We need to notice that there's a y in both terms, so why don't we factor out a y. Okay. And we want to get all of our y's on one side and all of our x's on the other side, so let's divide by a y over here and divide by x to the fourth on this side. We get 1 over y dy over dx is equal to 1 minus x over x to the fourth. And then we can loosely multiply this this differential and then multiply the dx out on this side to be on this side. Get the 1 over y dy is equal to 1 minus x over x to the fourth dx. And then from here we can integrate. This 1 over y, of course, will turn into the natural log of the absolute value of y. And we can rewrite this as x to the negative 4 minus x to the negative 3. And then doing out this integration, we get negative 1 over 3 x to the negative 3 and 1 over 2 x to the negative 2. And of course we have to have our arbitrary constant since this is an indefinite integral. And this will be our final answer, where c is an arbitrary constant.